All right, let's dive right in. Today, we're talking about one of the most powerful tools in any programmer's toolkit, the JavaScript array. Seriously, if you've ever wanted to manage a list of, well, anything, this is where it all starts.
Just think about it for a second. Every single time you open an app and see a list of things, your social media feed, the songs in your playlist, all those items in your Amazon cart, there's something behind the scenes keeping all that stuff organized. So, how do they actually do it?
Well, the answer, 9 times out of 10, is an array. An array is a super simple, super elegant solution to this whole problem. It's really just a container, a list that you can give one single name, and it holds a bunch of related information all together. Okay, this right here. This is the best way to picture it. Just imagine an array is like a shelf full of little boxes, all lined up in a row. The entire shelf gets one name, like C in this picture. Now, each box holds one piece of info, and it has its own unique position number. We call that an index. And here's the most important part, the thing you have to remember. In programming, we always start counting from 0. So the very first box is index 0, the second is 1, and on and on. So here's our game plan for today. First, we'll nail down what an array really is. Then, we're going to get our hands dirty and see how to actually create them and fill them with data. After that, we'll look at how to mess with that data, find what you're looking for, and at the very end, we'll even see how you can build grids with them. Let's add this tool to your toolkit.
All right, part 1. Let's make it official and lay down the ground rules for these awesome digital containers.
So these are pretty much the core rules. You've got one name for the whole collection. Every single item inside gets its own unique index, and I'm going to say it again because it's that important. The first one is always at index 0. What's really cool about JavaScript arrays is that they're dynamic, which just means you can add more stuff to them later on. And hey, if you ever need to know how many things are in your array, you just ask for its .length. Simple as that. Okay, so the theory is down. Now let's get practical. How do we actually make one of these things and start bringing our list to life? So, one of the classic ways to build an array is with the new array command. You can even tell it right away how many slots you're going to need. Then, you can use a simple loop, which is just code that repeats itself, to go through each spot one by one and drop a value inside. And boom, here's what that code actually produces. You can see 2 neat little tables, one for each array, showing the index right next to the value that our loop put in there. It's a perfect example of cause and effect. You write the instructions, and the computer builds this perfectly organized structure for you. Now, that loop method totally works, but let's be honest, programmers are all about shortcuts. A much faster and way more common way to do this is with what's called an initializer list. You just use square brackets, list out your items, and separate them with commas. You can even leave a spot empty just by adding an extra comma. Let's see what that looks like. And there you have it. The first 2 arrays look pretty normal, right? But check out that third one. See that spot we left empty? It's been filled with a special value, undefined. This is a super important little detail to catch. An empty spot in your list isn't just nothing. It's specifically undefined. All right, time for a pro tip. This is your #1 rule for arrays safety. You should never, ever try to grab an item from an index that's less than 0 or one that's bigger than the array itself. So if your array has 5 items, your valid spots are 0, 1, 2, 3, and 4. Trying to get item number 5 is a big no-no and will break things, trust me. Remembering this will save you so many headaches.
Okay, we can create them, we can fill them. So, now what? Let's talk about how we can actually work with the data inside, from looping through all the values to passing them around in our code.
So, when you want to do something to every item in your array, you use a loop. And you've basically got 2 main flavors. On the left is the standard for loop. It's like a robot that just counts up, 0, 1, 2, 3, and it will visit every single spot, even the undefined ones. But on the right, the for in loop is a bit smarter. It only visits the spots that actually have something in them, and it completely skips the undefined ones. And that little difference leads to a massive aha moment for coders. If you only want to work with the real data that's actually in your array, the for in statement is your best friend. It automatically skips those empty, undefined spots for you, which makes your code so much cleaner and safer. Okay, this next concept is a classic trap for new programmers, but getting it now will save you hours of pain later. So a function is like a little mini program that does a specific job. If you hand an entire array to a function, you're not giving it a copy. You're giving it the keys to the original. This is called pass by reference, and it means any changes that function makes are permanent. And here's the proof in the pudding. We start with an array, 1, 2, 3, 4, 5. We pass that whole thing to a function that doubles every value. And look at the output. The modified array is now 2, 4, 6, 8, 10. That change is permanent because the function was messing with the original array. It's powerful for sure, but you have to be careful.
But, and this is a big but, here's the flip side. If you only pass one single element from the array to a function, you're passing it by value. This means the function only gets a copy of that number. It can do whatever it wants with that copy, but the original value tucked away, safe in your array, doesn't change one bit.
Now, your arrays can get huge, right? We're talking hundreds, even thousands of items. You're not going to scroll through them one by one. So let's learn the essential skill of searching an array to find exactly what you're looking for fast.
Luckily, JavaScript gives us this amazing built-in tool called index of. It's so simple. You just tell it what you're looking for, and it zips through the array to find it. If it finds your item, it tells you the index, the position where it found it. And if it's not there at all, it just returns the number -1. That -1 is your universal signal for nope, not here.
And here we see it in action. Look at the top window. The user is searching for the number 15. The program uses index of. It gets back a -1, so it knows to say value not found. Simple. Now look at the bottom. The user searches for 16. This time, index of finds it, returns the index 8, and the program can tell us, found it. It's an element 8. So fast and efficient.
So far, we've only been looking at flat, simple lists. But what if you need to build something more complex, like a spreadsheet or a game board or a map grid? Well, for that, we can take our arrays to a whole new dimension.
This is where we get into multi-dimensional arrays, which is really just a fancy way of saying an array of arrays. On the left, you see the idea. We use two index numbers, one for the row, one for the column, to pinpoint any spot in a grid. Then look to the right. You can see how that code structure creates a real visible table. It opens up a whole new world for organizing data.
And just like that, you've got the core concepts of one of the most essential tools in all of programming. We've seen how to create them, fill them, work with them, and search them. The big takeaway here is that this isn't just theory. It's a real-world, practical tool. So my question to you is, what's the first thing you're going to organize with it?